Pardon me? Oh, this is not a Calc 1 thing. This is a college algebra thing. It's called partial fraction decomposition. Or partial fraction. See, what we're doing is we're developing a strategy here to integrate any algebraic function. In college algebra, you did something called the fundamental theorem of algebra, which said that any polynomial, no matter how big its degree, it can always be factored down into quadratics, that is second power factors, and linears. And if you count the complex numbers, you can even factor it all the way down to linears no matter what. So the thing is we just learned with trig substitutions how to do any quadratic factor. Any quadratic factor. Like suppose somebody asked us to integrate this. Wait a minute. That's a trig substitution. Now, it may not look like it to you yet, but it is. We realize that that is a prime quadratic. That does not factor further. How do you know that? Besides the fact I just told you. Tell me how you know. The discriminant. B squared minus 4 times A1 times C is negative. So this has no roots. This does not factor. What would you do in order to accomplish anything with this? I would complete the square. So I'm going to actually rewrite that as a 5. So this comes out halfway well. And I'm going to write that as x squared plus 2x plus 1 plus 4. Why did I do that?
Adding 0.
Exactly. Now I'm going to factor out a 4. This is not for the partial fractions. This is a problem you're going to see in 7.3. They're going to expect you to complete the square on some of these to turn it into this. By the way, now I'm going to factor out the 4. When I multiply the 4 back through, you see it cancels that. I have the x plus 1 squared. 4 times 1 is 4. So in other words, 1/4 integral dx, that's x plus 1 over 2 squared plus 1. Now do you see the trig substitution?
Yeah.
Tan squared plus 1 is secant squared. So now I'm going to say x plus 1 over 2 equal tan theta. Look at this one well. I guarantee you on Thursday, you'll see one where you have to complete the square in order to get the trig substitution. That's a promise. This technique will happen.
Why is it over 2?
Because I need tan squared. This whole thing needs to be a substitution. 4 is 2 squared.
Ah.
So now, this is 1/2 dx equals secant squared theta d theta. And I can rewrite this as 1/4 integral dx, where's dx is 2, secant squared theta d theta. The denominator is tan squared theta plus 1, which is secant squared. So this is 1/2 the integral of d theta. Oh, that came out nice, didn't it? Everybody with me on that? Which is 1/2 theta plus an arbitrary constant. And what's theta equal to? See, I didn't really, this is the arctan, isn't it?
Yeah.
We just derived the formula for the arctan in a different way. Before we derived the derivative of the arctan and gave us an integration formula. By using trig substitutions, we just invented the derivative formula of the arctan by integrating. So in other words, this is 1/2 the inverse tan. Don't call me. Nobody calls me. Nobody wants to talk to me. I don't care who you are. I'm hanging up, hanging up, hanging up, hanging up. Don't call me. I don't like people. the inverse tan of x plus 1 over 2. So, partial fractions are a way of splitting apart algebraic fractions. See, in other words, we can now integrate any quadratic. Any quadratic. If it's in the numerator, we integrate it directly. If it's in the denominator, we can complete the square. We can integrate any linear in the denominator. That's an ln. What happens when the powers in the denominator are bigger than 2, however? We can use partial fractions to split them apart. And that's what we're about to do. So suppose, oh, well, let's just get right into one of these. Oh, let's do a fun, oh, let's not do that to them yet. Larry, be a little bit decent. Yeah. Let's do, what a nightmare. Yes. Problem number 18 on page 541. That's the integral of, which one did I say? Number 18, and that's, well, forget the limits of integration for now. 3x squared plus 6x plus 2 over 18, x squared plus 3x plus 2. All dx, right? Did I copy that correctly? Anybody got any bright ideas? Oh, he noticed that the degree of the top was greater than or equal to the degree of the bottom. So I believe you said long division, didn't you?
Yeah.
That's what I thought you said. So he's going to take 3x squared plus 6x plus 2, and he's going to divide it by x squared plus 3x plus 2. Anytime the degree of the top is greater than or equal to the degree of the bottom, we have an improper fraction, algebraically speaking. And we're going to turn it into a proper fraction by division. This will go in there 3 times. So I get 3x squared plus 9x plus 6, and then I subtract. So minus 3x minus 4. So in other words, I've now changed this into 3 minus the integral of 3x plus 4 over x squared plus 3x plus 2 dx. Now the degree of the top is less than the degree of the bottom. We have a proper fraction now. I am going to now decide on my future course by asking myself whether the denominator factors or not. If the denominator does not factor, I'm back to 7.3. I'm going to have to complete the square and do a trig substitution. If the denominator does factor, then I'm going to use partial fraction decomposition and split it into 2 pieces. Notice the denominator factors. This is 3, excuse me, that 3 is still inside the integral sign. How egregious of me. So this is the integral of 3 minus 3x plus 4 over x plus 1, x plus 2 dx. And here's where we're going to see how many of you have any idea about partial fractions. If you have never seen the technique I'm about to employ, then, well, I'd say it's time to get religion. And I don't even believe in that stuff. So 3x plus 4 over x plus 1, x plus 2. What I realize is that I want to change this into 2 improper fractions. This was a proper fraction. I'm going to change it into 2 proper fractions. One of them with a denominator of x plus 1 and the other one with a denominator of x plus 2. Well, the degree of each of those denominators is 1. If they are proper fractions, what will be the degree of the numerators? Smaller than 1, which it, well, not nothing, 0. So they're constant. Tell me what's A and what's B.
Oh, I remember this.
Well, what I'm going to do is multiply both sides by the LCD. On the left-hand side, everything cancels. You get 3x plus 4 equals A times x plus 2 plus B times x plus 1. So I realize that equal mark is an incredibly powerful statement. That equal mark is claiming that the garbage on the left is equal to the junk on the right. Technical terms, garbage, junk. The garbage on the left is absolutely identical to the junk on the right, which means no matter what x I pick, I should get the same thing for both sides. So I'm going to pick x equal minus 1. Why in the world would I choose x equal minus 1? Well, here I get negative 3 plus 4. On the right-hand side, I get a times minus 1 plus 2, and notice that's gone. Now I know what a is. A is 1. Affected him deeply, huh? Well, what other x should I pick if I have a brain in my head? Which I really don't, but I pretend well.
-2.
Why negative 2, sir?
Another 0.
It generates another 0. So negative 2, that gives me negative 6 plus 4. Over here I get a 0 plus b times negative 2 plus 1. That says that b equals 2. So I have now rewritten this as the integral of 3 minus, well, 1 over x plus 1 plus 2 over x plus 2. And notice I have gone to something I can now integrate. I can integrate all this stuff. So I have the integral of 3 minus 1 over x plus 1 minus 2 over x plus 2 dx. What is the integral of 3?
3x.
Very good! The integral of 1 over x plus 1? ln
X plus.
absolute value x plus 1 minus 2 ln's
X plus 2.
absolute value x plus 2
Plus 2.
plus an arbitrary constant. And aren't you glad you know how to do partial fraction decomposition? What this means, I know you don't want to know this, but what this means is that you can now integrate any algebraic fraction, no matter what the degree of the top, no matter what the degree of the bottom, as long as it's just x's and numbers, theoretically, you and I can now always integrate it. If the degree of the top is greater than or equal to the degree of the bottom, we divide. We look at the bottom and we factor it until it's down into linears and prime quadratics. The prime quadratics we complete the square on, and we integrate with the trig substitution. The linears we integrate using ln. And we have partial fractions to split that apart. There used to be a section in this book where they then showed you a substitution that changes any sine or cosine, and therefore any trig function, into just algebraics, just x's and stuff like that, so we can integrate that. But they have decided that that's a little more difficult than what they want to throw at you, so it's no longer in the book. So they took that section that they lectured on and they made it one problem. They expect you to pick that up off of that, which I don't think I will be making you do. That's the Weierstrass substitution, and I don't even see it in here. So anyway, your life just got a lot more miserable. 7 point, if it wasn't already miserable enough, 7.4. Oh, shit. Hold on. 1 through 50, no mercy. 1 through 53 be odd. Oh, They do the Weierstrass substitution here. Yeah, it's very powerful stuff. I'm not gonna make you guys do it. You're welcome. I said you're welcome.
Thank you.
It's too bad too. It's really one of the more powerful things. If you're a math major, you wanna look at number 59. And I know a couple of you are, and you just are too embarrassed to say. But, yeah, you should do number 59. Anyway, let's also do number 65. And that'll be enough on the pleasantness. Now, there is one more new section to do. 7.5, the lecture on that is essentially very easy. 7.5 has all the different techniques thrown together into one section. 7.5 is the most important section of all for you to do, because that's what your test is going to look like. It's just going to be a list of integrals. It's not going to, see, on these, you kind of know what to do. If you're in 7.4 doing a problem, you're thinking, let me see, the title of 7.4 is partial fractions. If you're in 7.1 and you're doing a problem, well, 7.1, you'd say integration by parts, right? Because that's the title of the section. 7.5, you say the S word, right? The one that you say a lot when you're driving. Because it's just all of them together, all the techniques smashed up together, which is what your exam's going to look like. So 7.5, there's no lecture. And there's not that many problems, just 1 through 81, the all.
Let them in.
Yeah.
Can I just do 7.5 and that covers 7.34?
Now, this is a lot. You don't have time to drink tonight.
That's before they hide.
If there's any consolation, tomorrow's stuff is very light. Supposedly, we're going to cover 3 sections tomorrow. I can tell you that 2 of those 3 we're just going to barely touch on, and I probably won't even assign problems. 7.8 will be the only real new thing we do tomorrow. So I know this is a lot, but really 7.5 is the biggie. That's the one you want to make sure that you can do.
7.8 is
Is the improper integral.
okay.